This is 5.3, graphing radical functions. A radical function contains a radical expression with the independent variable in the radicand. When the radical is a square root, the function is called a square root function. When the radical is a cube root, the function is called a cube root function. So the parent function for the family of square root functions is f of x equals square root of x. And so this graph, if we plug in a 0, it would be at 0. If we plug in 1, square root of 1 is 1. And then another perfect square root would be 4. If we plugged in 4, we would get 2. So this is the general graph for a square root function. The domain is x is greater than or equal to 0, and the range is y is greater than or equal to 0. Square root functions are, we'll just say they have even indexes. Now the parent function for the family of a cube root function is f of x cube root of x. So let's plug in numbers. If you plug in 0, 0 is 1. 0 is 0. If you plug in 1, positive 1, you get positive 1. You plug in negative 1, you do get a negative 1. You're allowed to get that, so that is negative 1. The next perfect cube root is 8. Cube root of 8 is 2. So this is the parent function for a cube root. The domain and range are all real numbers. Cube root functions have odd indexes. Okay, so an odd index. So here, let's graph this radical function. So we make a table of values and sketch the graph. So let's see. We can't have any negative values, so let's start with 0. When we plug in 0, we get 0. Let's plug in another good number. Let's plug in 4. We would get 1/4 times 4 is 1. And then another good number would be 16. Because 16 over 4 is 4. And then, and then the square root of 4 is 2. The index is even. So, to graph this, I'm going to make this my y-axis, this is my x-axis. And so I have 0, 0. Then I have a point at 4, 1. And then that's all that I can fit in my graph, which is fine. So you know that the graph does this. The domain is when x is greater than or equal to 0, and the range is the same. Y is greater than or equal to 0. This next one, we have negative 3 cube root of x. So let's just plug in a number, plug in 0. So we would get 0. 0 times negative 3 is 0. If we plug in negative 1, we would have negative 3 cube root of negative 1 is negative 1. So we would get a positive 3. Negative 1, positive 3. If we plug in a positive 1, we get negative 3 times 1, which would be negative 3. Okay, and then the graph would look, let's see, like this. Here. Go this way. We could pick another point. We picked 8, right? We plug in 8. Let's plug in negative 8. Cube root of negative 8. That would be negative 3 times negative 2. So that would be positive 6. 1, 2, 3, 4, 5. Oh, that was close. It's positive 6. And the next one would be negative 6. Let's reflect it on the other side. 2, 3, 4, 5, 6. Okay, so then you can get a better picture of what the graph looks like. Okay? Now let's look at transformations. You should be able to fill the next piece out here.